Welcome to this visualization of a cycloid, the fascinating curve traced by a point on the circumference of a rolling circle. Here, the black dashed circle rolls without slipping along a straight line. The red point on the rim traces out the cycloid curve. As the circle rolls forward, notice how the red point initially dips below the center line, reaching its lowest point. This corresponds to when it's directly under the center of the circle. The point then rises and reaches its maximum height when it's at the top of the circle. This motion repeats with each full rotation. You can see the wave-like arches forming. Each arch corresponds to one complete revolution of the circle. The blue line shows the full path traced by the red point, the mathematical cycloid. The green dot marks a fixed point on the circle's rim. It helps visualize the rotation as the circle rolls. Its circular motion around the center emphasizes the link between linear and angular displacement. The cycloid is not just a pretty curve. It has deep mathematical significance. It appears in problems of optimal motion, such as the brachistochrone and tautochrone problems. This animation helps reveal the geometric origins of the cycloid and its physical intuition. Thanks for watching. For further exploration, try plotting the epicycloid or hypocycloid curves by changing the tracing point's position.